Have you ever wondered what might happen if a nuke were to be detonated in the Mariana Trench? Well, while we may not be able to actually do it due to concerns of international treaties and such, we can calculate what might happen in the event of something similar, namely the annihilation that results from the contact between matter and antimatter. In order to establish a baseline of modern antimatter knowledge, it should be known that the most massive antimatter ever made was 18 anti-helium 4 nuclei using a billion gold ion collisions in New York. And if antimatter and its reciprocal, such as a positron and electron, collide, it should annihilate and convert into pure energy, according to CERN. Furthermore, theory states that the annihilation of matter and antimatter should be 100% efficient in mass and energy within the system. This is because of the law of conservation of mass and energy. However, although it is 100% efficient, only 50% of energy from that annihilation is considered useful energy. This includes thermal energy and work, among other forms. The rest is converted into ionizing radiation, which is insignificant for this hypothetical. The Mariana Trench is roughly 11 kilometers deep with a temperature of 2.5 Celsius and a specific heat of 3.993 joules per gram Kelvin. The boiling point of seawater is 102 Celsius and its density is roughly 1025 kilograms per meter cubed. The pressure at the Mariana Trench is 1.16 times 10 to the 8th pascals. The largest nuke whose underwater detonation was calculated was the Tsar Bomba, which released 2.1 times 10 to the 17th joules, or 210 petajoules of energy. 85% of its total energy released was considered to be useful energy. This was predicted to create a gas bubble that was a kilometer in diameter before collapsing due to the high water pressure. The main equation we are going to use is Einstein's famous mass-energy equivalence formula, E equals c squared m. In conjunction with this, we will be using a theoretical equation that models the gas bubble formed by an explosion. The radius of this underwater explosion will be equal to the cube root of 3/4 pi times 40% of usable energy all over pressure plus 101,325 pascals. 40% represents the proportion of energy from each cycle of an oscillating explosion bubble that remains for the next cycle. In the context of underwater explosions, not all the energy from the initial explosion is used in the first bubble pulse. A significant portion of the energy is conserved and used in subsequent pulsations of the bubble. For our hypothetical, we will use three objects: the largest amount of antimatter ever produced, 18 helium-4 nuclei, a Rocky Mountain oyster, and Atom Mazzara. First, the 18 helium-4 nuclei. The mass of a single helium-4 nuclei was calculated to be 4.00 something AMU as shown on the screen, and converting to kilograms we get 6.646 something times 10 to the negative 27 kilograms, depicted here. That means 18 helium-4 nuclei will have a mass of 1.196 something times 10 to the negative 25 kilograms. Doubling the mass for the addition of both antimatter and matter, the total mass is 2.392 times 10 to the negative 25 kilograms. Plugging that into the equation E equals c squared m, we get a resulting energy of 2.16 times 10 to the negative 8 joules. And to find the usable energy of that explosion, we just divide that value by 2, getting a final value of 1.08 times 10 to the negative 8 joules, resulting in an explosion with a radius of only 2.07 times 10 to the negative 6 meters, or 2.07 micrometers, which is above average in my opinion. Next, the Rocky Mountain oysters. The mass of a single Rocky Mountain oyster is, on average, 30 ounces. Converted to kilograms, it is 0.85. Doubling the mass for the addition of both antimatter and matter, the total mass is 1.7 kilograms. Plugging that into the equation E equals c squared m, we get a resulting energy of 1.54 times 10 to the 17th joules. Furthermore, the usable energy is going to be 7.7 times 10 to the 16th joules, giving us a final explosion radius of 401 meters. I bet that one doesn't have any personality. Finally, we move on to our biggest and final subject, atom. Atom has a supposed mass of 180 pounds. Yo, are we sure that's right? Which converts to 81.6 kilograms. Doubling the mass for the addition of both antimatter and matter, the total mass is 163.2 kilograms. This results in a total energy of 1.47 times 10 to the 19th joules and 7.34 times 10 to the 18th joules of usable energy, creating an explosion with a radius of 1,830 meters. That's gotta hurt. However, even if these amounts of energy seem small, remember that the other 50% of energy that is expended by annihilation is turned into ionizing radiation, which will permeate the ocean and create radioactive water, causing major destruction to local life as many organisms will have their DNA shredded by all of the radiation. Furthermore, the amount of energy needed to blow up Mount Everest is about 10 to the power of 18 joules, meaning that by annihilating atom, we can unleash enough energy to level a little over 7 Mount Everests.